Let's say if we started at -4 and we travel to position 3, and then after that we travel from position 3 to position -2. What is the distance traveled by the object or the particle? And what is the displacement? So let's calculate the distance. First we traveled from -4 to 3, that's 7 units to the right, and then we travel from 3 to -2, that's 5 units to the left. To find the distance you simply add those values, so we traveled a total of 12 units. Now to find the displacement, there's two ways we can do that. We could use the equation, it's the final position minus the initial position, so the final position is negative to the initial position was -4, so it's -2 minus -4, which is the same as -2 plus 4. Whenever you have two negative signs next to each other, you can make it a positive sign, so therefore it's +2. So the distance traveled is 12 units, but the displacement is only +2 units. And it makes sense, because we started at -4, and then we ended at -2. So the net effect is we only travel 2 units to the right. If you just compare the start and the finish, where you started, where you ended, so that's our displacement. It's just the distance between the final position and the initial position. Now let's break it up into two parts. The displacement for the first part is +7 because we traveled 7 units to the right. The displacement for the second part is -5 because we traveled 5 units to left. If you add those two numbers, +7 and -5, you get the net displacement of +2, which is what we have. Now if you want to calculate the distance, you simply make these two numbers positive. Instead of using -5, you use +5, so 7 plus 5 will give you this value 12. So hopefully this helps you to distinguish distance from displacement. Now let's say if a person walks 3 miles east, and then 4 miles north. Calculate the distance and the net displacement traveled by the person. So to find the total distance, you simply need to just add everything he traveled. 3 miles east and 4 miles north, so he traveled a total distance of 3 plus 4, or 7 miles. Now, to find the displacement, we need to find the distance between where he started and where he ended. So this is where he started, and this is his finish point, or where he ended. So we got to find the direct distance between those 2 points, and that's going to give us the displacement. So let's call it delta x. The displacement, you can call it something else. If you want, you can call it s, or delta y. But you know what? Since we're not traveling in the x direction, we're also traveling in the y direction. Let's just call it s. What we need to do is use the Pythagorean theorem. So in this case, we know that c squared, the hypotenuse, is equal to a squared plus b squared. So s squared is going to be 3 squared plus 4 squared. So that's going to be 9 plus 16, which adds up to 25. And so the displacement is going to be the square root of 25, or 5. So the net effect is that the person traveled 5 miles in that direction, even though he actually walked a distance of 7 miles. So keep in mind the displacement is the distance between your final position and the initial position. So I'll give you now some problems to work on about the distance and displacement. Problem number 1. An object moves from position -8 to 12, and then to position -20. What is the total distance traveled by the object, and what is the displacement? Number 2. Sally travels 50 meters west, and then 120 meters south. How far did Sally travel, and what is her net displacement? So go ahead and try this problem. I'll check your answer in the comment section. See you in the next lesson. Bye-bye.